Today we will discuss about standard deviation. In our last class we have already discussed about mean deviation and range from measures of dispersion, right? So the last formula that we will be discussing is about standard deviation, and there is another term that is closely associated with standard deviation, which is called variance. So standard deviation is defined as if you have a ungrouped set of data, that is x1, x2 up to xn, and we have n observations, then standard deviation is denoted by this symbol sigma and is given by this formula sigma equal to plus minus root over 1 by n summation I goes from 1 to n xi minus x bar whole square. Now this x bar is the arithmetic mean of this same data set, right? So you will have to find out the sequence is, first you will have to find out the arithmetic mean, then you will have to subtract the arithmetic mean from all of this. That means you will subtract the arithmetic mean from this one, from this one, from this one. So these are basically, if you subtract something from a value, that is called deviation. So this is basically called deviation, mean deviation. So we are deviating the mean, then we will square it. That means xi minus x bar, the differences will be squared, then all the differences will be added, then that will be divided by the number of observations, and last we will take the square root. Now if we don't consider the square root, then the formula becomes sigma square equal to 1 by n summation xi minus x bar whole square, right? So this is with square root, this is without square root. So if we ignore the square root, that means basically we square this formula, it is called variance. So in short, variance is the square of standard deviation, right? So this is the formula for standard deviation in case you don't have frequencies or tables, right? Now in case our data consists of frequencies like f1, f2, fn for every x1, x2, xn, that means we have a group frequency or continuous group frequency, then the formula becomes sigma square equal to 1 by capital N. Now what is capital N? Capital N is sum of all the frequencies, right? I goes from 1 to n. So if you have n frequencies, if you add all of them, you will get capital N. So in this case, in our previous formula for ungrouped data, it was small n. Small n means number of observation, and in case of group frequency, it is capital N, that is total frequency. Now this part is same as before, the only thing is different is we will have to multiply the frequencies. Now if you take the square root, you will get the standard deviation. So this symbol sigma, this is called sigma, this is a Greek letter sigma. Sigma denote standard deviation and sigma square denote variance, right? So but if you are not comfortable with this symbol sigma, you can simply write standard deviation and VAR, variance for variance, SD for standard deviation. That is also correct, right? So if you are not comfortable with the symbol, you can simply denote it as SD and VAR, right? So these two are the formula. So let's try some examples. The first example is very simple. We have 5 numbers 25, 53, 40, 32 and 30 and 32, and we are supposed to find out the standard deviation of this particular data, right? So this is basically your x1, this is your x2, this is your x3, this is your x4 and this is your x5, right? Now in case of ungrouped data, your standard deviation, now one thing that you have to remember is that while calculating standard deviation, we don't directly calculate standard deviation, rather we always calculate variance first, because variance formula does not involve square root. So we will calculate variance first, then we will take the square root of that variance and we'll obtain the standard deviation. That's the rule. So these are your data. Now we are supposed to find out the variance first, right? So the formula for variance is sigma square is equal to, or variance of x, the same thing. Variance of x is also denoted by sigma square, is, in case of ungrouped data, it was 1 by n summation I goes from 1 to n xi minus x bar whole square. Now what is n? N is the number of observations. So here n is 5, right? Because we have 5 observations. Now what is xi? Xi is this x1, x2, x3, x4, x5. Every time the value of this sum changes, the value of x will also change, right? Now only thing that we don't know so far is this x bar. Now what is x bar? It is the arithmetic mean. Now what is arithmetic mean? Arithmetic mean x bar for ungrouped data is given by summation of x divided by n, right? So here x bar will be 25 plus 53 plus 40 plus 30 plus 32 divided by number of observation is 5, right? So if we solve this, we will get x bar. The next thing is you will have to subtract this arithmetic mean from all of them, right? That means 25 minus x bar, 53 minus x bar, then 40 minus x bar, then 30 minus x bar, and then 32 minus this x bar. Now what is x bar? X bar is the value of this formula, right? This is your, so this one is your first step. First step is to find out your x bar. Second step is to find out the difference of all the numbers and your x bar. What is, you found out arithmetic mean. This is second step. The third step is to take the square of these values. Whatever value you got here, you will get a value, right? So every value here, there will be some negatives, some positives, so all of them have to be squared. 25 minus x square, then 53 minus x bar, this is square. 40 minus x bar, this value is square. 30 minus x bar, this value is square, and 32 minus x bar, this value will be square. And number 4 is you will have to take the sum, right? You will add them, right? If you add them, you will get up to this point, right? This is summation xi minus x bar whole square. The last step is you will have to divide it by 1 by n summation xi minus x bar whole square. Now what is summation? This sum of these numbers divided by n. N is number of observations 5, right? That will give you variance, right? This is variance. So the last step is standard deviation will be plus minus root over variance. These are the steps. So let's go to the solution. Here, for ease of calculation, we normally create a table. Now if you don't like to create tables, you can calculate them manually also, but creating a table makes calculation easier, right? So our values are 25, 53, 40, 30 and 32. These are our x. We have added them. Add is summation x, right? Summation x. Now for from summation x, we can calculate x bar. X bar is summation x divided by n. In this case, n is 5, summation x is 180. Therefore x bar is summation x n is 180 by 5 equal to 36. So we got our x bar as 36, right? So that is your step 1. Step 2 is you will have to subtract this 36 from all of them. That means 25 minus 36, which will give you minus 11. 53 minus 36, which will give you 70. 40 minus 36, which will give you 4. 30 minus 36 minus 6. 32 minus 36 minus 4. right? So this is your step number 2. Then you will have to square them. That means minus 11 square 121, 17 square is 289, 4 square is 16, 6 square is 36, and 4 square is 16, right? So we got the squares, right? Next step is to, this is your step number 2, this is step number 3. Step number 4 is you will have to add them, right? Summation. So if I add all these numbers, I got 478. That is step number 4. What is step number 5? Step number 5 is to find out your variance using this formula. 1 by n summation x minus x bar whole square, which is equal to 478 divided by n is 5. So ultimately I got the variance as 95.6, right? So as soon as you got the variance, you can go to calculate standard deviation. What is standard deviation? It is plus minus root over variance. Variance is equal to plus minus root over 95.6, which is equal to approximately 9.78. So this is how we calculate standard deviation for ungrouped data. Now at this point I will like to add something. Now in this example our arithmetic mean is 36, right, which is an integer without any decimal value. So that's why subtracting 36 from all this number leads to integer values, and that's why their squares are also integers, so calculations are a bit easier. Now imagine your x bar is say 47.08. In that case you will have to subtract a decimal value from all of this. So this will lead to decimal values. Those decimal values will again have to be squared, so that will lead to more decimal places. So ultimately the calculation requires will be very much, right? So you will need a lot of calculations. For that reason we have modified the formula of variance and standard deviation so that we don't have to do such big calculations, right? Let's go back to that formula, how we can restructure the formula for variance so that it reduces the amount of calculation, right? So we will explain that using the formula for frequency distribution, right? So variance sigma square for frequency distribution is given by 1 by capital N summation I goes from 1 to n fi xi minus x bar whole square. This is the formula, right? So here before starting this formula I would like to add, or I will like to note down few properties that we will use. First of all, the first property is what is the value of n? N is nothing but summation I goes from 1 to n fi, that is total frequency. Next thing, what is this x bar? X bar is 1 by n. In case of group frequency, what is the formula for mean? It is I goes from 1 to n xi fi, right? That is the formula. These two are two properties or two rules that we will use here. Next one is, in case of summation, if you have two series a plus b, this can be written as summation a plus summation b, right? So summation can be splitted, right? Summation of two variables is equal to summation of first plus summation of the second one. This is our third property. And the last property is, if you have a constant c into x, then the constant can be written outside, right? C is a constant. For example, if you have 2 times of x, then we can write 2 summation x, because 2 is a constant, right? So these are some properties that we will use while simplifying this formula, right? So let's get back to here. So this is equal to, we will keep the first term 1 by n same. Next 1 by I goes from 1 to n fi. Now this thing is, we can consider this as summation a minus b whole square. We can consider it as a minus b whole square. Now what is a minus b? A minus b whole square is a square minus 2 times of ab plus b square. So this will be xi square minus 2 times of xi into x bar plus x bar square, right? A square minus 2 times of ab plus b square. Fine. In the next step, 1 by n summation I goes from 1 to n. We will multiply this fi to all of them. Basically we are doing a into b plus c plus d. This is equal to ab plus ac plus ad. We are multiplying a to all of them. Same case here. So fi xi square minus 2 times of fi xi x bar plus fi x bar square. Now all of them are under the summation sign, right? This is equal to 1 by n. Now we will use this formula, that means, or property. If you have summation on a bracket, that is a plus b, we can write them individually, right? Summation a, summation b. So consider this to be a, this to be b, and this to be c. That means summation a minus b plus c, right? So if this is summation a minus b plus c, that can be written as summation a minus summation b plus summation c. So the same thing we will do here. So summation I goes from 1 to n fi xi square, right? The next will be minus I goes from 1 to n 2 times of fi xi x bar, right? And the last term will be plus summation I goes from 1 to n fi x bar square. Okay, this equal to 1 by n summation I goes from 1 to n fi xi square. The first term will be intact, nothing changed, right? Next, so in this term here you can see that 2 is a constant and this x bar is also constant. How we can tell whether x bar is constant? Because there is nothing called I, right? In fi and xi there is I and there is a changing variable which is I. So fi xi are non-constant, they are changing, but 2 and x bar are constant. Now according to this property, constants can be written outside. So here we can write 2 x bar outside. Summation I goes from 1 to n fi xi, right? Plus here also this term is constant, so x bar square summation I goes from 1 to n fi, right? So that is, we have in this step we have simply took the constant terms outside the summation sign, right? Now we will multiply this 1 by n to all of them. So 1 by n summation fi xi square I goes from 1 to n minus 2 times of x bar into 1 by n summation fi xi plus x bar square into 1 by n summation fi. I goes from 1 to n. We have simply multiplied this 1 by capital N to all of them, right? So the first term will be same. I goes from 1 to n fi xi square. Next term, this is 2 times of x bar will be same. Now what is 1 by n summation fi xi? From this property, it is nothing but x bar. So in place of this, that means in place of this term, we can write down x bar, right? And the last term is x bar square into. Now what is summation fi? Summation fi is capital N divided by capital N. So this will be capital N divided by n, right? That means 1. So we will simply ignore that term, right? So this is, so the last line we got 1 by capital N summation fi xi square minus 2 times of x bar into x bar plus x bar square. Now what is x bar into x bar? That is 2 times of x bar square plus x bar square. So minus 2 plus 1, so it will be minus 1. So this is equal to 1 by n summation I goes from 1 to n fi xi square minus x bar square, right? So this is our final formula for variance. Now if we compare the first formula, that is original formula, with the last formula, what is the difference is? The difference is that in this formula you have to subtract the arithmetic mean from all the numbers, right? Even if your arithmetic mean is a decimal value, that means it contains decimals, then also you will have to subtract it from all the numbers, which will lead to some more decimal values. Then you will have to square them more decimal places, and so the calculations will be large numbers, right? But in this formula you don't have to subtract the arithmetic mean from all of them. You will have to subtract the square of the arithmetic mean only once. That's the difference between this formula, right? So what formula we will use for variance? So variance, the formula that we will commonly use to calculate variance will be sigma square equal to 1 by n in case of xi square minus x bar whole square. This is in case of ungrouped data. So basically here you will have to square the data, whatever you are given, you will have to square them, add them, divide them by n, then subtract the mean. Now one mistake that students often do is they consider this 1 by n to be multiplied to all of them. Now that is wrong. You don't consider this 1 by n multiplied, so consider this as a separate term, this as a separate term. That means 1 by n summation x square is a separate term, minus x bar whole square is a separate term. That please remember this. 1 by n summation x square is a different thing, x bar is a different thing. Now that will be cleared from this approach, right? In this case, when we do calculations, we are going step by step, and this value and this value are separate terms, right? So this 1 by n is a separate term multiplied only with this summation fi xi square. So that's why this is a separate term, this is a separate term, right? So for ungrouped data, that means when you don't have frequencies or tables, you will use this formula to calculate variance, 1 by n summation xi square minus x bar square. Now if you have frequencies, the formula will be 1 by capital N summation fi xi square minus x bar whole square. So remember, I am telling you again and again that this is a different term, this is a different term. This 1 by n is not multiplied with this x bar. Fine. So using this formula you calculate variance, then we calculate standard deviation simply taking the square root. Fine. So that is one way of reducing calculations. But still, if your numbers, that is your x or your frequencies, are quite big, still you will end up having a large calculations. Now, like arithmetic mean, where we used to have a new data set called d is equal to x minus a by h, right? In case of arithmetic mean, we used to reduce this calculation using this approach, where we make a new data set d using the formula x minus a by h, where a and h are some constants. A is commonly taken as the middlemost value of x, right? And ultimately we found out that x bar is equal to a plus h times of d bar. This was the formula for arithmetic mean, right? Now if you do the same approach in case of variance, then variance of x bar is equal to h square times of variance of d, not x bar. Variance of x is h square times of variance of d, or standard deviation of x is equal to h times of standard deviation of this d, right? This is the formula. Now unlike arithmetic mean, in case of variance of standard deviation, this a is not to be considered. We don't consider this a in the final formula, right? So we will combine this formula with this approach to reduce our calculation. So let's go to another example. Example number 2. Here we are supposed to calculate the standard deviations for these values with these frequencies. The values are 10, 15, 20, 25 and 30. The frequencies are 5, 12, 16, 12 and 5, right? So let's go and calculate this. So we are given values of x, 10, 15, 20, 25 and 30, and frequencies are 5, 12, 16, 12 and 5, right? So straightforward way, if you don't consider, I will solve this in two approaches, right? There will be two approaches in which I will solve this. So method 1, let's call this method 1. Now method 1, the formula is sigma square is 1 by n summation fi xi square minus x bar whole square. This is the formula that we will use, right? This is variance. We will ultimately calculate standard deviation just taking the square root. So x we have, f we have, so we need x bar. Now here x bar is summation fx by capital N, right? That is the formula for x bar in case of group frequency. So that means we need the multiplication of f and x, and we also need the multiplication of f and x square, right? So we will calculate fx and we will calculate fx square, right? Fx is 5 into 10, 50, then 12 into 15, which is 180, then 320, then 300, and last is 150. Fine. So we need the total of f, right? Why? Because this will give us capital N. So total of this is equal to 50. So if I add 5, 12, 16, 12 and 5, I will get 50, which is the total frequency. If I get this fx, that means 50, 180, 320, 300, 150, I will get 1000. Now what is 1000? 1000 is, this is summation fx, right? And let's calculate this also, fx square. So the value of fx square, that is f is 5 and x square is 10 square, that is 100. So the value will be 5 into 100, that is 500, right? Similarly, 12 into 15 square, this will give you 300. This is 16 into 220 square, this will give you 6400. This one is 7500 and 4500, right? So these are the values of fx square. Now why we need fx square? To calculate this part, right? So that means we need the summation. So if I add all of this value, I will get summation fx square, which is equal to 21600, right? So we got the total frequency capital N, we got summation fx, we got summation fx square. So now what is x bar? X bar is summation fx by capital N. What is the value of summation fx? That is 1000. Capital N is 50. So the answer is 20. So what is our x bar? That is 20, right? Next we need to find out sigma square. Sigma square is 1 by capital N summation f x square minus x bar whole square. What is capital N? It is 50. What is summation fx square? That is 21600, right? Minus what is x bar? X bar is 20 square. So this over 21,600 by 50 will give you 432, and this is 400, right? So the ultimate value is 32. So the variance is sigma square equal to 32. So now what is standard deviation? Standard deviation is root over of variance, right? Which is equal to plus minus root over 32, which is equal to plus minus 5.66 approximately, right? So that is method 1. Now in this method, see that despite we have used a new formula, right, still the calculation fx square are big, right? The values are very big, 500, 6400, 750, right, 750045. So these are very big numbers. So there is another way to reduce that using the approach of finding out a new data set D, right? So we will use the second method. Method 2. So in case of method 2, this is more simple, x, f, right? So we have values of x 10, 15, 20, 25 and 30. The values of f are 5, 12, 16, 12 and 5, right? So total we already know is 50, right? So now next step is we will calculate a new variable called d, which is equal to x minus something divided by something. Now this divided by something is normally the gap between your x. What is the gap? Here 10, 15, 5, 5, 5. The common gap is 5. So we will divide it by 5. and this constant, that is what we will subtract from x, is normally the middlemost value. Here we have 5 observations, so the middlemost value is 20, so we will write 20. So what will be the value of 10? In this case, this is 10 minus 20 divided by 5 is equal to, why 10 minus? Because x value is 10, right? So 10 minus 20 is minus 10, minus 10 by 5 is minus 2. Similarly, this will be minus 1, this will be obviously 0 because 20 minus 20, this will be 1 and this will be 2, right? So we found out that the values are minus 2, minus 1, 0, 1 and 2, right? So then we will calculate f into d and f into d square. Because in this case our objective is to find out variance of d. We will calculate the variance of d. We will completely ignore this line now. We will ignore this line. We will think that this is our table. This is what we are given, right? We are given d and we are given f, right? And you have to find out the variance of d. Ignore for this, for some time, ignore this column x, right? So we have certain values d and their frequencies. That means minus 2 is repeated 5 times, minus 1 repeated 12 times and so on. So what will be the formula for d, variance of d? It will be 1 by n summation f d square minus d bar whole square. This will be the formula for finding out variance of d, where d bar is 1 by capital N summation f d, right? So once you calculate this one and this one, then you can find out variance of x using the formula h square into variance of d. Now what is h? H is the number that we divide. What we have divided? 5, right? So in our case h will be 5, right? So this is minus 2. Now fd, what will be fd? Fd just multiplication, so this is minus 10, minus 12, 0, 12 and 10, right? Now what is fd square? Fd square will be f into d square. Now 5 into 2 square is 4, so this is 20. 1 square and 12, so this will be 12, this will obviously be 0, this will be 12 and this will be 5 into 2 square is 4, 4 into 5 is 20, right? So now to calculate variance of d and d bar, we need summation fd. Summation fd is total of this column. Now what will be the total of this column? 10 minus 10, 12 minus 12, so this is 0. That means summation fd is 0. Now what is summation fd square? This is 20 plus 20, 40, 40 plus 24 is 64, right? So we got summation fd square is equal to 64, right? So now we will calculate d bar. D bar is 1 by n summation fd, which is 0 because summation fd is 0. So d bar is 0 and summation and variance of d is equal to 1 by n summation fd square minus d bar whole square, which is equal to 1 by n is 1 by 50 into summation fd square is 64. Now d bar square, d bar is 0, so we don't have to write it. Now this is equal to 1.28. So we got variance of d as 1.28. So from variance of d, how we can calculate variance of x? Just simply multiplying by h square. Therefore variance of x is equal to h square into variance of d. Now what is h? H is this value 5. So 5 square into variance of d is 1.28. So this is equal to 25 into 1.28, which is 32. So variance of x we got as 32 using method 2. Now using method 1 also we got variance of x as 32, right? So that means both the methods are giving the same value, 32. Now you can find out standard deviation of x by simply root over 32, right? Or if you want to shorten the calculations, you can directly calculate standard deviation of x. Standard deviation of x will be h times of standard deviation of d. So from this step, that means variance of d, you directly calculate standard deviation of d, which is root over 1.28. And in the last step, you can just multiply by 5 into root over 1.28. You will get the same result in both the cases, right? So this is how we calculate standard deviation if you have frequencies. Now this method 1 without creating a new data set, this is also correct way, but involves larger numbers in calculations, right? This is a more simple way of calculating the same data, right? Now let's go back to our third example. This is calculating standard deviation from this data set, right? 10 to 20, 20 to 30, 30 to 40 and all. So let me write down the values. Now in this case we will directly go to the shortcut method. That means we will create a new data set d and we will also use the new variance formula. So what is given? We are given certain marks which are 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. And we have number of students, that is frequencies, right? 3, 12, 18, 12 and 5. These are the frequencies, the same frequencies as the last one. So the total will be 50. Now in case of class intervals, what we do? We calculate mid values, and these mid values act as your value of x. So what will be the mid value here? 10 and 20, the middlemost number will be 15, right? 10, 20, the middlemost value is 15. Here it will be 25, here it will be 35, 45 and 55. So these are your values of x. Now instead of x, we create a new data set or new numbers called d. d will be x minus something divided by something. Now divided by this value is commonly the gap between them. So what is the gap? From 15 to 25 the gap is 10, 10, 10, 10. So we will divide it by 10. Now this number is normally the middlemost value. What is the middlemost value? It is 35. So it will be 35. Now writing down you don't have to manually calculate the value of d in such a situation when they have common difference and there is only one mid value, right? This value will automatically be 0. This will be minus 1, minus 2, 1 and 2. You don't have to calculate them. They will be this always, right? So minus 2, minus 1, 0, 1. Now to calculate standard deviation or variance, we need FD and FD square, just like the last example, FD and FD square. So FD is 3 into minus 2. So this is minus 6, minus 12, 0, 12 and 10, right? So the total of this is minus 2, minus 12 and minus 12 got cancelled. 10 minus 6 is 4. So this is summation FD. Now what is FD square? FD square will be 12, 12, 0, 12 and 20. So this will total to 56. Now what is 56? 56 is summation FD square, right? So now D bar is 1 by capital N summation FD, which is equal to 1 by 50 into summation FD is 4, right? So this is equal to 0.08, right? And then we can calculate variance of D is equal to 1 by n summation FD square minus D bar whole square, which is equal to 1 by 50. What is summation FD square? 56 minus D bar is 0.08 whole thing square. So this will give you this is 1.12 and this one will be 0.0064. So this will lead us to 1.1136. Now what is this? This is the variance of this new data set D, right? But we need variance of the original data set X. So what is the formula? Variance of X is H square into variance of D. Now what is H? H is the number that we divide to create D, which is 10 in this case. So 10 square into variance of D is 1.1136. What is 10 square? That is 100. So it will be 111.36, right? 111.36, that is variance of X. So standard deviation of X will be plus minus root over 111.36, right? So see how the calculation is drastically reduced when you use this approach, right? So this is how we calculate standard deviation for different types of data: discrete, discrete grouped and continuous group data, right? Now with this we close the chapter measures of dispersion, under which we have studied three formulas. One is called range, right? So we have studied what is range. Range is nothing but maximum minus minimum, right? Then we have calculated mean deviation. Mean deviation is 1 by capital N summation I goes from 1 to n fi modulus of xi minus x bar, right? And what is variance? And this is 1 by n summation I goes from 1 to n fi xi minus x bar whole square. That is variance, and if you take the square root, you will get square root of variance is equal to standard deviation. So that is all about measures of dispersion. That's all for this one. See you in the next one.